Hello, welcome to King of Review. My name is Kerwin and today's class is gonna focus on the special products. I'm so happy to meet you guys and I hope my lecture would be helpful for you. Okay then, let's get started. Special products. When I was a little child, I enjoyed playing with bricks. I made some houses, cars, and something like that. What about you? Did you like it as well? Okay, I'm gonna use these bricks to explain special products today. Let's take a closer look at the square of a binomial sum. Okay, the first one is just squaring a binomial. So if I have a plus b squared, I know that your temptation is gonna say, oh, isn't that a squared plus b squared? Is it true? Okay, today's lesson is starting with this question. I'll show you whether it is true or not. I told you that I'd explain this using bricks, right? Okay, there is a square brick with each side a long. Then what's the area of this square? The area would be a squared, right? Okay, in this situation, I'm gonna add some bricks to make a bigger square. I added two rectangular bricks with lengths A and width B. So the areas of these bricks are AB each, right? Okay. I think we need just one more square to fill here, right? Then each side of this square should be B, right? And the area of this small square would be B squared. Okay, now I want to find the area of this whole square. To find the area, we need to find the length of each side. Okay, the length of this side would be A plus B. Understand? And this side also A plus B. So the area of this whole square is A plus B squared. Right. Now, I'm going to pick these bricks off to show you what's equal to a plus b squared. Firstly, the original one, and then two rectangular bricks. Lastly, the smaller square. Okay, now I'm going to write down the area of these bricks. The original one, a squared, and two rectangular bricks, a plus b, plus ab, plus AB, and then lastly the smaller square plus b squared. Oh, there are like terms inside, so we can combine these. So this is equal to a squared plus 2ab plus b squared. Let's go back to the question. Is it true that a plus b squared is equal to a squared plus b squared? Absolutely no. As you can see here, there is something more, right? Now, you have to resist every temptation to this, okay? Please don't forget these bricks. This time, I'm going to explain this in algebraic perspective. The exponent of these two means there are two parentheses, right? A plus B times A plus B. In the last lecture, we've covered that there are two ways to solve multiplying binomials, right? The distributive property and Fuller method, right? Okay, this time I'm gonna use the distributive property to solve this problem. So we can distribute like this: A times A plus B, right? And then this B times A plus B, right? Okay, so this is equal to A times A plus B, and then plus B times A plus B, right? Okay, so this is equal to a times a, that's equal to a squared, right? Plus a times b, that's equal to ab, right? Plus b times a, that's equal to ab also. And then b times b, that's equal to b squared, right? So this is equal to, okay, let me look at here, a plus b, a plus b. We can combine these like terms, right? So a squared plus 2ab plus b squared, right? This is the answer. So a plus b squared is equal to a squared plus 2ab plus b squared. Okay, to summarize, in general, whenever you have a squared binomial, let me do it this way. The first one a plus the last one b squared is the first one squared plus 2 times the first one times the last one and plus the last one squared. Okay? Actually, I remember this in a song. Do you know the song Twinkle Twinkle Little Star? Okay, let's sing together. A squared b squared plus 2ab. Okay, can you do it again? A squared b squared plus 2ab. It's easy and it'll be continued. Okay, now we have an example. This is a multiplication of this binomial times itself. You always need to remember that. It's very tempting to think that it's just 2x squared plus 7 squared, but no. You have to expand it out. Okay, just think a song. A squared b squared plus 2ab. Okay, as shown above, this is equal to the first one 2x. The first one 2x squared plus the last one squared plus the last one squared, and then lastly plus 2 times the first one, that is 2x, right, times the last one, right? Okay, let's solve this. And it's equal to 2x squared, that's equal to 4x squared, right? Plus 2 times 2x, that's equal to 4x, and 4x times 7, that's equal to 28x, right? And then 7 squared, that's equal to 49, right? So 4x squared plus 28x plus 49. This is the answer of this 2x plus 7 squared. Okay, can you understand? Okay, now we're gonna take a look at the square of a binomial difference. This one is also squaring a binomial but difference. A minus b the whole squared. I think you may hesitate to say, oh, isn't that equal to a squared minus b squared? Is it really true? Okay, I'll also show you if this is true or not using the bricks. Okay, here, there is a square each side a long as well. The area would be a squared, right? This time, I'm going to subtract 2 same rectangular bricks from this square. Length A and width B. So the areas are AB respectively. Oh, we subtracted twice this small square, right? With each side B long. So don't forget to add the area of this small square here, right? The area is B squared, right? Okay, then now we're gonna find the area of sky blue square which is subtracted. Here, this area, okay? the length of this side would be a minus b, and the length of this side also a minus b. Therefore, the area of this square, right, is a minus b, the whole squared, right? And I'm gonna pick these bricks off as well to show what's equal to a minus b, the whole squared. Firstly, there was a square with each side a long, right? And then I subtracted the two same rectangular bricks, right? And don't forget to add this small square, because we subtract twice this area, right? So add b squared here. Okay, now let's put down the areas of these bricks. Okay, a squared minus ab plus b squared, right? And this is equal to a squared minus 2ab plus b squared. Now we find that a minus b, the whole squared, is not equal to a squared minus b squared, right? Everybody clear? Okay, now I'm gonna solve this in algebraic perspective. We know that this is equal to a minus b times a minus b, right? And we can solve this using both the distributive property and the FOIL method, right? Okay, this time let's solve this with FOIL method, right? Okay, FOIL, F, multiply the first terms, right? So this is the first terms, right? This is the first term. So, which is equal to a times a, right? Okay. And then secondly, O, which means outer terms, right? So this is outer terms, right? So plus a times negative b, right? And then I, that is inner terms, right? This is inner terms, right? So plus negative b times positive a. And then lastly, L, last terms, right? Multiply the last terms. This is the last terms, right? So this is equal to plus negative b times negative b. Okay? Okay, let's continue. A times a, that's equal to a squared, and a times negative b, that's positive times negative, that's equal to negative, right? So this is equal to negative ab, right? And negative b times positive a, this is also negative ab, right? And negative b times negative b, negative times negative, that's equal to positive. So this is equal to plus b squared. And then inside, look at this, inside those are like terms, right? So we can combine. So a squared minus ab, that's equal to minus 2ab, and then plus b squared, right? So this is the answer of a minus b, the whole squared. Okay? Okay, let's summarize this. In general, whenever you have a squared binomial, please do it this way. The first one a minus the last one b, the whole squared is the first one squared minus 2 times the first one times the last one, and then lastly plus the last one squared. Okay, and remember that the minus here between a and b, this minus comes to here in the middle, right? And I also remember this in a song. Okay, let's sing a song together. A squared b squared plus 2ab, a squared b squared minus 2ab. It's easy, okay? Okay, now we have an example here. Please don't have any temptation to say it's equal to 3x squared minus 5y squared. Okay, please don't say that. Okay, instead of that, use this formula and think about the song. A squared b squared plus 2ab, a squared b squared minus 2ab. Okay, the first one minus the last one, and the whole squared, that's equal to the first one squared, so 3x squared, right? And then this is minus, right? Minus 2 times, and then the first one, this 3x, right? 2 times 3x and times the last one, that is 5y, right? And then lastly plus the last one squared, right? So 5y squared, right? Okay, let's continue. And this is equal to 3x squared. 3x times 3x, that's equal to 9x squared, and negative 2 times 3x, that's equal to negative 6x, and negative 6x times 5y, that's equal to negative 30xy, right? And then plus 5y squared, that's equal to 25y squared. So this is the answer of this, right? Can you understand this? Okay, until now we learned about the square of a binomial difference. Okay, lastly we're gonna focus on the product of a sum and a difference. This is also a very important concept in algebra. Now we have a plus b times a minus b. This is not scaring. What would be equal to this? This is not scaring thing, but we'll get scare things. I'm gonna show you this using bricks as well. Okay, here there is a square with each side a long, and the area is a squared. Now I added a rectangular brick with length a and width b to make this length a plus b. And I subtract the same rectangular brick to make this area, this length, a minus b, right? Oh, I should subtract this area, right, to make a plus b times a minus b. Okay, now the area of this rectangle is a plus b times a minus b, right? Now I'm gonna pick these bricks off to see what a plus b times a minus b is equal to. There was a square and I added a rectangular brick, and then I subtracted the same rectangular brick, and then lastly I subtracted a small square as well, right? In mathematical notation, it's a squared plus ab minus ab minus b squared. Okay, let me have an attention here. You know, this is 0, right? Plus something and minus the same thing is nothing, right? It's same here. This is 0 as well, right? So this is equal to a squared minus b squared, right? From the product of a sum and a difference, we got difference of two squares, like here, right? So when you see this product of a sum and a difference, you can use the distributive property or for method to solve this, but don't waste your time. We have a very useful shortcut. As you can see here, the first one plus the last one times the first one minus the last one is the first one squared minus the last one squared. Everybody got it? It's easy, right? I'm really sorry, I don't have any song for this yet. Sorry, yeah. Okay, let me have an example here. Please don't distribute this. And please don't use for method either. We have a beautiful formula here, right? We have a beautiful formula here, right? So these are the first one, right? And these are the last one. So the formula is the first one squared. So 90 squared. And then minus the last one squared. 6 squared. So this is equal to 90 times 90. That's equal to 81 t squared, right? And then minus 6 times 6. That's equal to 36, right? So 81 t squared minus 36. This is the answer of this one, right? Okay, until now we talked about the product of a sum and a difference. It is a long journey to come here. We'll take a break here a little bit and continue on the next lecture. We'll do the challenge for advanced learners and review of special products. It is Kevin, and thank you so much for watching this video. See you on the next lecture.